Hello students, welcome you all to the next session regarding discussion on gear drives. So in the previous sessions we have discussed regarding the power transmission through belt drives. We have gone through the length of belt calculation for the open belt drive case, cross belt drive case, then the ratio of tension in the belt drives and many more things. So the belt drives we can use for particular applications only when the shaft distances are at a larger distances. The space between the shafts is large. Apart from that, we can use the belt drives when they are positioned parallel itself. But if there are shafts, if they are intersecting, non-intersecting or non-parallel, then you cannot go for using the belt drives. As well as even if the distance between the shafts is very less, then we are impossible to use the belt drives. At that time, we go for a next type of drive where the power can be transmitted, that is the gear drives. So almost everybody, I think, have seen the gears in your daily life applications, especially right from your watch to your vehicles. In your watch also, if you're having an analog watch, you can observe when the watch is being repaired that there are some gears which are moving towards one another, which are used for transmitting the power from one end to the another end itself. So let us start with the basics of these gear drives. So basically what it is a gear. So if you observe the gear, it is almost, there is a wheel which is circular in shape, or you can say that of a wheel which is provided with the teeth on its circular surface. So if you observe, if a wheel provided the teeth is there, it is known as gear. So why this teeth have been provided? So if you observe this in this particular figure here, from this end, I want to transmit the power to the other end where this is the shaft. And to transmit this one, you can see the position of this gear is not at one place itself. It is moving from one end, rotating from one end to the other end itself. So in that way, to transmit the power from one shaft to another shaft in such a way that when the distance is very less. So here you can see the distance between three shafts. This is the first shaft, this is the second shaft here, and this is the third shaft. So transfer distance, if the distance between the shafts is very less, then you can see that we are using these gear drives for transmitting the power between two shafts when their center distance is very less. Now, the purpose of using the gears is, you can see in this picture, see one gear, this gear, it is rotating faster. Now it is slowing down. Again, it rotates faster. Similarly, you can see here the second gear, third gear. So what it means, you can increase the speed or decrease the speed very easily in terms of in the gear drives when compared to the belt drives. That is, the speed of rotation you can be increased or decreased at any point of time. Similarly, these gears, they can rotate in either directions. It can rotate in the forward direction or it can even reverse the direction of rotation also, which means in either directions it can rotate. Then another important thing is, if you see this particular sketch, the axis of this one, as it is rotating here, you can see the position of this axis, it is shifted to some particular time. So what you can say that you can move the rotational motion to some different axis also. So the gear can be moved to some different axis around the rotation of time. And along with that, the rotation of the two axes, they can be easily synchronized. It can be easily synchronized. Then another important thing is, in the gear drives, it need not be that the shafts should be placed in parallel position. They can be placed in the intersecting part, non-parallel, or even in the inclined position also. So for all types of possibilities, we can use the gear drives when compared to belt drives. But here also the gear drives are having some advantages points when compared to belt drives, and there are also some disadvantages. We can see these when we move one by one for the next slides. So moving on to the next slide. So there are gears, many types of gears we have seen, and many times we are using particular gears for particular applications itself. So the different types of gears which we are using, how we are classifying them? We are classifying them based upon the shaft mounting axis, or you can say that the positioning of the axis of the shaft or where the gears have to be mounted. So for your syllabus, depending upon the position of the axis of the shaft, we are classifying the gears into 5 types. The first one is the spur gear, second one is the bevel gear, third one is the helical gear, fourth one is the worm gear, and the fifth one is rack and pinion gear. Moving on to the first one, spur gear. So if you observe both the pictures here, if you observe in this picture, here you can see there are 2 gears. The axis, these are the 2 shafts on which these gears have been mounted. This is gear 1, this is gear 2. Gear 1 is mounted on this particular shaft, gear 2 is mounted on this particular shaft. If you see the axis of these 2 shafts, how they are being mounted, both are parallel to one another. You can see both are parallel to one another. So if you see the picture in the side animation view, you can see here how the gears are being rotating here. So if I need to transmit the power from this point to another point, here at this position when the teeth are coinciding or meshing with one another, then the power of this particular shaft, it is transferred to this shaft with the meshing of this teeth of the both the driver and the driven gear. So in very simple words, how you can define the spur gears? The spur gears are the gears which are used to transmit power between which kind of shafts? Parallel shafts. So this is shaft number 1 and this is shaft number 2. So if you observe here, the axis of this both shaft, this is the axis 1, this is axis 2. Both axes are parallel to one another. First important point. Second important feature of this spur gear is if you observe the teeth structure, if you observe the teeth structure, if you can see the teeth is cut in a straight manner on the periphery of the wheel. So here also you can see how the teeth is being cut. Here also it is also cut in a form of a straight manner on the periphery of the teeth. So this is the important peculiarity of this one, the spur gear. So it is this reason that the shafts are being mounted parallelly, and as the teeth are cut straight, they are mounted very easily parallel to the rotation of the shafts. So when we cut the teeth in straight manner, then the machining or the production of teeth or manufacturing of the gear teeth, it is very much simple in nature, or you can say that it is the most economical type of production. So you can manufacture the things very within less amount of time. The gear teeth can be produced within a less amount of time, and it is the simplest type of gear design. So generally you are using this spare gear, especially in the machine tool boxes. If you have observed, we are using the gear boxes of different types of mechanisms. Then the wind up alarm clocks or the world clocks, then wrist watches, and even some precision measuring instruments also. Everybody, I think you have observed these things. But apart from this spur gear also some limitations. So as I was telling you that these are used for mounting for only 2 parallel shafts. If there are some perpendicular shafts or inclined shafts, you cannot use the spur gear. So if there is any mechanism or device where you want to position the shafts perpendicularly or some inclination, then you cannot use these shafts. So this is a very important disadvantage. Second important thing is when we are having a straight teeth cut on the periphery of this wheel, then the noise produced is very much high. That is the reason that for the gears we are adding some lubricants oil such that along with the noise there may be even some friction also reduced. So when they are producing more noise, because there is more contact surface occurring over the full face of this teeth, where all these teeth are under continuously meshing with one another. Meshing is something, but it is they are meeting with one another continuously. So these are some of the points with respect to the spur gears. Similarly, when you go for the next set of gears, that is the bevel gears. So if you observe from the previous slide and this slide, say here I was telling you that both the shafts are being how they are positioned parallelly, but if you observe for the next slide, see how the shafts have been positioned here. You can see in the other picture, see this is the axis of the one shaft and this is the axis of the another shaft, how it is being positioned. If you observe carefully, they are positioned at right angles to one another 90 degrees. So this is the important peculiarity of this particular gear, that is the bevel gear. So in the bevel gear, you can say that it is used only when we are having intersecting shafts at right angles to one another. This is the first important point. Second important point is, if you observe the design of this particular gear, if you observe the design of this particular gear, it is a thing what it is like a conical shaped structure. If you observe here, it is like a conical shaped structure. So from the tip end to the base of the gear, if you observe, it is like a conical shaped structure. Yes. So it is shaped like a section of an cone, and this is used for transmitting the power between the two shafts which are at right angles to one another. So here, if you observe, here also we are having a straight teeth, or there will be some even helix teeth also. But these teeth, if you observe carefully, at one end, it is being cut with greater thickness, and as it moves to the other end, its thickness goes on decreasing. So what you can say that the teeth which are cut here for a bevel gear, they may be straight as you are observing in this picture, or in this picture if you observe, they are in the form of some helix, in the form of some helix angles, bent at some angles. So along with that, the very important thing is these teeth, where they have been developed, they have been cut on the conical surface of these gears. They have been developed on the conical surface of these gears. That is, on this outer conical surface, the teeth have been developed. So when the teeth have been developed on this conical surface, from the base towards the meeting point of these two gears, you can see here the thickness of these teeth is not the same. At one end, at the base, the thickness is high. As we are moving towards the meeting point of the two gears, their thickness goes on reducing. So that is the reason that the diameter of the cone is the greatest where at the base part here, and the teeth will be thicker here itself. So therefore, these bevel gears especially we are using for efficient transmission of power, or you can say that for most efficient means of power transmission. The good example for this one is, if you have observed a drill bit at your home, or for a drill chuck, whatever the gear is used to fix the spindle, it is nothing but it is of a bevel gear itself. If you have at your home a drill chuck, you can see that to fix the spindle you need a chuck key. The chuck key and that particular drill spindle, how they are intersecting, they are perpendicular to one another, and they are nothing but the bevel gears itself, because they act as efficient means of transmission. That is the reason that when you are fixing the chuck, you are rotating in the vertical direction, where the drill in the hole, it happens in the horizontal direction. So both are perpendicular to one another. These are some of the points which are respected to our bevel gears. Similarly, when we go to the next set of gears, that is the helical gears. So here, if you observe carefully, this was the bevel gears, the spur gears. So in the spur gears, you observed here the teeth are cut straight. Their shafts are being positioned parallelly. Second, here the teeth are developed straight or maybe helix on which type of shafts, intersecting shafts, and the surface of the gear is conical shaped, cone shaped structure. But now if you come for the helical or helix gears, here if you see how the teeth have been developed, see if you observe both these gears, these teeth, they have been inclined to some angle. So here also you can see they have been inclined to some angle. So the most important feature of this helical or helix gear is the design of the teeth. So this design of the teeth, it is neither straight or nor spiral, but it is inclined to some angle that is around less than 20 degrees. We call it as an helix angle. So the angle at the helical gear tooth is referred to as the helix angle, and this angle should be less than 20 degrees. Why less than 20 degrees? Because if the angle exceeds beyond 20 degrees, then there will be more excessive end thrust. If there is more end thrust, then sometimes it may lead to the failure of the teeth also. To avoid that, maximum angle of inclination preferred is 20 degrees. So when the angle of helix is developed on this gear teeth, the other important thing is you can fix, or you can shaft the design the shaft in any manner, and you can position the shaft in any position also. That is, you can use this helix gear for parallel shafts, you can use for intersecting shafts, or for even non-parallel and non-intersecting shafts also. See, this is a very important feature of this helix angle. So helix gears, where you can use, once more I am repeating, you can use them for the parallel shafts as you are seeing right now in the sketch, or you can use for non-parallel shafts. Apart from that, you can use for intersecting shafts or non-intersecting shafts. So you can use for non-parallel shafts in this fashion, you can use for intersecting shafts in this fashion, or even you can use for non-intersecting shafts. So everywhere or wherever, in which position if you want to mount the shaft, you can prefer in that particular direction this type of gears. So this plays a very important role. So if you're using the parallel shafts, the helix gear, what happens, they are carrying, they have the ability to carry more amount of load in particular to spur gears. So if any vehicle, if it is carrying a capacity of around 40 tons using spur gears, the helix gear can carry for the same load up to around 60 tons, which means it is having capacity to carry more amount of weight. Why? Because if you compare with the spur gears, if you see here, the contact surface of the teeth within the two gears, it is very much more when compared to the spur gears. That is the reason that these teeth are very much tough, hard, and they can bear more amount of weight. And when we go for this helical gears, as we have discussed, we need especially for heavy applications, especially for the power transmission in the vehicles or automobile sectors, we are preferring this one, that is the helical gears. So therefore, the gears which we are using for meshing here, they can produce some thrust force even in the axial direction also. But the designing of these gears plays a very important role. So the manufacturer who is working or designing these helical gears, you should have a sound knowledge regarding the angle at which has to be inclined for the development of the teeth. First important point. Second important point, when compared to other two gears, this is a little bit expensive process. That is the reason that we're especially using for high load applications, especially for the automotive power sectors. Next, worm gears. So if you observe this type of particular mechanism, the worm gear, you can see here, this is similar to the spur gear itself, the straight teeth is there, but here is another one gear. So if you observe the axis of these two shafts here, if you observe carefully, this is rotating along this particular axis. So if you observe carefully, in this particular, this is rotating along this particular axis, whereas this particular upper gear is rotating in this particular axis. So if you observe in the side view, if you observe in the side view here, this is the axis of the worm, this is the axis of the worm, whereas this is the axis of the wheel, that is the worm wheel, that we call it as the spur or the other wheel. So if you observe both the axes, yes, they are perpendicular to one another, but the thing is they are not intersecting with one another, which means the important feature of this gear mechanism is these are used for perpendicular right angles, but for non-intersecting shafts. So the power in this type of gear arrangement, it can be transmitted for non-intersecting right-angled triangles, non-intersecting right-angled gears, which are inclined at 90 degrees to one another. So if you observe this worm gears, sometimes the design of this worm gears, it may resemble the same of the helix gear or the spur gear, but the only thing is they are placed at right angles to one another. They are placed at right angles to one another and are non-intersecting. Now, so this is that the meshing, if you observe here, the meeting part here in this mechanism, the meshing is a very important self-locking mechanism. So this is the wheel, this is the wheel, and this is the worm. So the meshing is self-locking because the power is transmitted from the worm wheel to, from this worm to the worm wheel. So once this worm rotates, then only its power it is transmitted to the worm wheel. which means it is like a self-locking mechanism, because here, unlike the helix, bevel, or the spur gears, there is no reverse direction of rotation, which means the power has to be transmitted from worm to the worm wheel. Here, the power cannot be transmitted from the wheel to the worm. That is the reason that we call it as the meshing as a self-locking mechanism. So, worm can turn this gear, but this gear cannot turn the worm. And why this happens? If you observe here, the teeth which are developed on this worm wheel, the contact surface of this worm wheel when compared to this worm. For the worm wheel, the contact surface is very less. Whereas for the worm gear, here the contact is very much high. That is the reason that even though it tries to rotate this worm, it cannot rotate very easily. It will not rotate. That is the reason that we call it as a self-locking mechanism, and this worm gear is always used for as the input gear mechanism, especially when we want to achieve some gear reduction ratio or to reduce the speed, then we are preferring this worm gear mechanism. So generally when we are using this one for the driving and the driven shafts, the reductions you may do from 20:1 to 300:1, or even you can greater go also. But keep in mind that these are positioned at right angles to one another, and both the shafts are non-intersecting. Worm can drive the gear, but vice versa is not possible. That is the reason that we call it as a self-locking mechanism. Then the last type of gear, that is a rack and pinion gear. So if you observe the sketch carefully, a straight bar is there, which is having gear tooth profiles on it. We call it as the rack. And on this one, there is a circular wheel which having a teeth, straight teeth. We call it as the pinion, which means rack is a straight bar with a profile of gear teeth of infinite length and diameter, which is under meshing with a pinion gear wheel, circular wheel. So what happens here? It is responsible for converting the linear movement of the rack into rotary motion of the pinion, or rotary motion of the pinion into the linear movement of the rack, which means converting the motion from one type of movement to the other movement, linear movement of the rack into rotary motion of the pinion, or rotary motion of the pinion into linear movement of the rack. So this rack, it can move both forward and backward directions very easily. That is the reason that these racks we having designed with the machined ends can be joined together to make any desired length very, very easily. So this finds a wide application, especially in the steering system of the cars and heavy vehicles also. That is the rack and pinion. Along with that, many times our windshield wipers which we are using for our vehicles, they are nothing but working on the same mechanism which is present in the cars, powered by a rack and pinion mechanism itself. So very simple to understand. The rack and pinion, rack is a straight bar which is having a teeth cut on its periphery, whereas pinion is a circular wheel having some teeth. So here the linear motion of the rack, it is converted into rotary motion of the pinion, or rotary motion of the pinion converted into linear motion. So generally we are using the rack and pinion for the steering mechanism in the cars or windshield wipers also of the cars itself. These are some of the things with respect to the gears. Now, some of the advantages of the gear drives and disadvantages, as I was telling you. So advantages, I told you that we can transmit the power between the shafts which are at shorter distances when compared to the belt drives. Apart from that, we can transmit the power between the parallel shaft. You can transmit the power between the non-parallel shaft, as well as you can transmit the power between the intersecting and non-intersecting shafts also. So in the belt drives, we have discussed that there we could transmit the power only for the parallel shafts, but you can transmit the power here for any kind of shafts also. Then the gear drives, why we are preferring this time? As I told you, the distance between the shafts is very, very less. So that is the reason that we are preferring the gear drives. So here the power which has to be transmitted, it can be transmitted with a constant speed ratio. Whereas in the belt drives, there was a ratio of belt tensions T1/T2, but here it is not the case. So you can say that there is a constant speed ratio. Then when compared to the belt drives, gear drives are having a high transmission efficiency. The efficiency of transmission is very much high when compared to the gear belt drives, because here there is no development of the slip or the creep factor. That is the reason that there is high transmission efficiency. And this gear drives you can use for any kind of power transmissions. You can use for low power transmission, you can use for medium power transmission, or even you can use for high power transmission also. These are the things we need to understand, that you can use for low, medium, or even high power transmission also. But apart from this, the gear drives are having some disadvantages which compared to the belt drives. One important thing is they are unsuitable to use when the center distance between the shafts is very large. So I was telling you, if you are using, you are operating a floor mill. So in the floor mill, you have seen to run the floor mill, the belt is coming from the motor towards the mill. So if you are using the gear drives, that is not so feasible. Their center distance is very large. That is the reason that the gear drives cannot be used when the center distance between the shafts is very large. Second important thing is, whenever the driver and the driven gear, they want to meet with one another. So when they are meeting with one another, you are saying that there is development of some friction between these two teeth, which means every time or after using some amount of time of meshing, you should go for lubrication. Otherwise, there will be more amount of noise produced, and with more amount of noise produced, even vibration plays a major problem. So at higher speeds, what happens, many times you are adding some lubricating oil such that to reduce the noise as well as the friction can be reduced very easily. So compared to belt drives, cost of production of gears, it is comparatively higher in nature. We cannot use the gear drives very easily. Its cost is very much higher when compared to the belt drives. So during the usage of the gear drives, you have seen there are many number of teeth present on these gears. There you can see this is one teeth, this is second teeth, this is the teeth you can see here. So in this, if any one teeth fails, then the entire whole arrangement fails. So damage to damage to any single teeth, it will affect the whole arrangement, which means it stops the working mechanism itself. These are the cases to be taken when you are operating with the gear drives. When you are operating with the gear drives. Now, some of the comparison. What are the advantages and disadvantages? They are the same comparison which are made here. So the first comparison is regarding the positive drives. So belt drives, they are non-positive drives. So why they are non-positive drives? As I was telling you that because of the slip formation, there is some transmission which has to be reduced in power transmission. That is the reason that the belt drives are non-positive drives, whereas the gear drives are positive drives. Second important thing is, the belt drives are very much efficient when the center distance between the shafts is large or it is greater in nature. Whereas for the gear drives, the center distance between the shafts has to be almost as less as possible. You can say small. Then you can transmit the power in the belt drives only when we are having parallel shafts. But here you can transmit for any position, parallel, non-parallel, intersecting, as well as non-intersecting shafts also. So when along in the belt drives, as I was telling you, when there is a slip formation, then when there is a slip, you cannot get the exact velocity ratio. But here there is no slip formation. As there is no belt, there is no slip. As there is absence of a slip, automatically the velocity ratio maintained will be constant throughout the entire mechanism. So in the belt drives, you can transmit power only of moderate type, but whereas you can transmit low, medium, as well as high power also. Now, if you go for the power transmission efficiency in the belt drives, we are having low power transmission efficiency, but for the gear drives, we are having high power transmission efficiency. In the belt drives, we are using the belts. That is the reason that the friction happens between the belts and the pulley itself. Therefore, their lubricant is not required because the belt is elastic material. So there is no much more friction when compared to the gear drives. But here the gears, they are metallic in nature, and when the two gears, they are completely meshing with one another, there is more amount of noise produced, completely wear and tear happens. That is the reason that to remove all these properties, the gears have to be undergone frequent lubrication, which improves the other properties also, Now, velocity ratio. So already this term we have discussed in the belt drives. In the belt drives already we have discussed that when the power is to be transmitted from one shaft to the another shaft, there has to be one the driver pulley, another has to be the driven pulley. The same is applied even for the gears also. So here also, to transmit the power from one gear to another gear, one has to be a driver gear, another has to be a driven gear or a follower gear. So the same definition we are writing here. That is it is defined as the ratio between the speed of the driven gear to the speed of the driver gear. So in the sketch you can see this is the driven gear and this is the driver gear. So if you observe here carefully in the sketch, the driver gear, it is rotating in clockwise direction, whereas the driven gear rotates in counterclockwise direction, or it is anti-clockwise direction. Keep this in mind. The gears, they can transmit power only when they are rotating wherever the gear meshing occurs, or you can say that the point where both the two gears are meeting with one another, their direction of rotation are completely different. So one is rotating in the clockwise direction, another has to rotate in the opposite direction, that is the anti-clockwise direction. Then only the power from the driver shaft can be transferred to the driven shaft. So here, what are the assumptions made here? Let us see. See, let D1 be the pitch circle diameter of the driver gear. Yes, D2 be the pitch circle diameter of the driven gear. T1 is the number of teeth present on this driver gear. T2 be the number of teeth present on the driven gear. N1, it is the speed of the driver gear. N2 is the speed of the driven gear. Now, as I told you, we are not using any belts, so automatically there is no formation of a slip turn, which means the slip factor is absent here. There is no slip. So when there is no slip, then between the mating teeth, the linear speed of the driving gear, always keep in mind, whatever the linear speed of the driving gear is there at the meeting point, it will be the same linear speed even for the driven gear also. So between the mating teeth, that is at this point where the teeth are meeting with one another, we call this as mating teeth here, where the two gears are meeting one another, mating teeth, the linear velocity, I am repeating the word, or the linear speed of the driving gear, it has to be equal to the linear speed of the driven gear. So depending upon this, how we can write this one, let us see. So linear speed, how we can write, that is V1, V is equal to pi D1 N1 is equal to pi D2 N2, V1 is equal to V2. Pi D1 N1 is equal to pi D2 N2, where pi is the circumference, pi D1 is the diameter of the driver gear, D2 is the diameter of the driven gear, N1 is the speed of the driver gear, and N2 is the speed of the driven gear. Now, on simplification, what we get as per our definition, velocity ratio is nothing but ratio of the driven gear. So in our figure, which is a driven gear, gear 2 is a driven gear, which means N2 by N1 is equal to D1 by D2. This is our definition, that is the speed of the driven gear to the speed of the driver gear, which is equal to the diameter of the driver gear to the diameter of the driven gear. Now, along with this one, here another one term adds for the gears, that is regarding the number of teeth also. Let us see how it happens here. See, the circular pitch for both the mating gear remains the same. That is, here this is the circular pitch according to their definition. This is the circular pitch here, where the two gears teeth are meeting here. This is the circular pitch which remains the same for both the gears. That is, this is one and this is. So the red color circular pitch, where it is meeting with the yellow color circular pitch, both pitches are same. Circular pitch of the driver gear is equal to circular pitch of the driven gear. So therefore, how we can say regarding circular pitch? You can write it as circular pitch is equal to pi d1 t1 for the driver gear, which is also equal to pi d2 by t2 for the driven gear, or it is on simplifying d1 by d2 is equal to t1 by t2. So what is d1 by d2 in the previous slide? If you observe in the previous slide, d1 by d2 is n2 by n1. So here what it happens, d1 by d2 you can write it as n2 by n1 also. That is the reason that substituting equation 2 in equation 1, what we can have n2 by n1, this I have taken n2 by n1 is equal to d1 by d2 is equal to t1 by t2. Or what you can say for the gear drives, the ratio, this entire ratio is the thing what it is, the velocity ratio up till here. If you include this one, becomes even the transmission ratio itself along with the number of teeth also, Now, next, why we are requiring this one to discuss regarding the gear trains. So what are these gear trains? So we have seen individually we are using the spur gear, helical gear, bevel gear, but these gears they not be only one, two, their number may increase depending upon the applications also. So if we are using two or more gears to transmit the power from one end to another end, then those type of gear assemblies we call it as gear trains, or the arrangement is known as gear train. So this number of gear we decide how it depends upon what is the final velocity ratio we need for driving that mechanism, or you can say the desired velocity ratio, and along with the relative position of the axis of the shaft. So as I was telling you, we may use parallel, non-parallel, intersecting or non-intersecting shafts. So depending upon what is the velocity we need, or what is the position of the shaft we need, depending upon all these factors, we are deciding how many number of gear trains have to be, how many number of gears have to be used. So depending upon the arrangement of gears, that is the number of gears as well as how they are positioned on the shaft, we are classifying them into different types. Number one is the simple gear train. Number second comes the compound gear train, and number third comes the reverted gear train, and fourth one is epicyclic gear train. For our syllabus, we need to discuss simple gear train as well as compound gear train. So let us see regarding how we can find out the velocity ratio for a simple gear train as well as compound gear train. Now, simple gear train. So in the simple gear train, what he says, simple gear train is a gear train where you can mount any number of gears over the shaft, or you can say that if a number of gears which are mounted over the shaft such that for each shaft, you can see here, for one shaft you are having only one gear, or in very simple words, what you can say that for each shaft, if there is only one gear, this is first, this is second shaft, second gear, similarly third shaft, third gear, which means for each shaft, if there is only one gear, then you can say that it is nothing but a simple gear train itself. It is a simple gear train. So simple gear train is nothing but the number of gears used such that for how many number of gears, each gear has to have separate shaft for itself. Each shaft carries only one gear. So in the picture now you are observing that there are two gears, which means these two gears should have two shafts. Shaft 1, gear 1, shaft 2, gear 2. In that, this one is the driver gear, another one is the driven gear. So already we have written the assumptions. N1 is the speed of the gear 1, which is a driver. N2 is the speed of the gear 2, which is the driven gear. What is T1? Number of teeth which are present on this gear 1. The teeth are not shown here, just we are showing a circular pitch in the sketches. Similarly, for the driven gear, T2 is the number of teeth present on the driven gear. Then, how we can write the speed ratio? So, for the gear drives, just now we have discussed how we can write the speed ratio, velocity ratio. N2 by N1 is equal to T1 by T2, or in simple words, what you can say that the speeds are inversely proportional to the number of teeth. That is in this particular type of relation, that is N1 is inversely proportional to 1 by T1. Yes. So similarly, if you observe for N2, it is also inversely proportional by 1 by T2. So this it means. So in gear drives, speeds are inversely proportional to the number of teeth. N2 by N1 is equal to T1 by 2. That we have achieved here. So always keep in mind for gear drives, the speeds they are inversely proportional to the gear teeth or the number of teeth. Now, or the speed of the driven gear to the speed of the driver gear is equal to number of teeth on the driver gear to the number of teeth on the driven gear. This is equation number 1. Now, in this sketch, what you can see here, you can see here there are 4 gears. In this 4 gears, already they have shown here that this is the driver gear, gear number 1. Gear number 4 is the driven gear. And if you observe carefully, for all these 4 gears, each gear is having its own shaft. This is shaft number 1 for gear 1, shaft 2 for gear 2, gear 3 is mounted on the same shaft, gear 4 is mounted on its own shaft itself, which means each gear is mounted on its own shaft. Then if you observe the direction, gear 1 it is rotating in clockwise direction, gear 2 rotating in anti-clockwise direction, then gear how it is rotating? It is rotating in a clockwise direction. Gear 4 it is rotating in anti-clockwise direction. So here what is our driver gear 1? What is your driven gear 2? So we want to transmit the power from gear 1 to gear 2. But the problem here is the distance between these two gears, it is very much. But instead of that, if we think that if you want to design the gears of a greater diameter such that, see, this is the driver gear here, which I am showing here right now, and this is the driven gear. So no doubt I can transmit the power from this driver gear to the driven gear, but the problem here is what happens? The size of the gear increases, both the gears increases, the teeth profile that increases. So the work done is more to transmit the power. The same amount of power is transmitted, but to transmit the same amount of power, you have to do more amount of work. That is the reason that what we are using here, we are using small gears to place in between the driver and driven gears, whose function is to transmit only the power from the driver to driven. They are not changing the entire velocity ratio. Keep in mind, whatever the power or the velocity ratio is to be transmitted from 1 to 4, the velocity ratio is not changed. But the thing is, they are provided only to accommodate the space between the driver and the driven gear. So these gears, we call them as idler gears. So the gears between the present between the driver and the driven gears, we call them as idler gears. So in this sketch where there are 4 gears, gear 2 and gear 3 are idler gears. They are idler gears. Now let N1, N2, N3, N4 be the speeds and T1, T2, T3, T4 be the number of teeth respectively for all these 4 gears. Now we are assuming that gear 1 rotates in the clockwise direction. When the gear 1 rotates in the clockwise direction, gear 2 should rotate in opposite direction, that is anti-clockwise direction. Then what will be the velocity ratio for gear 1 and 2? That is N2 by N1 is equal to T1 by T2 in terms of teeth. Here we are not writing in terms of which diameter, we are writing in terms of teeth, T1 by T2. So when gear 1 drives gear 2, this is the driver right now, yes. Then when it is driving this gear 2, for some amount of time, gear 2 becomes a driven gear. So what it becomes now? N2 by N1 is equal to T1 by T2. This is equation number 2. Now, when we have written for these two, let us move for the next set. Now from gear 2, the power has to be transmitted to where? Gear 3. Gear 1 has given its power to gear 2. Now gear 2, it has to transmit its power from 2 to 3. So now which is the driver from gear 2 to 3? This becomes the driver for gear 2 and gear 3 becomes the driven gear. So now how I can write the velocity ratio between gear 2 and gear 3, or you can say that gear 2 is now driving gear 3. Gear 2 is now driving gear 3, where gear 2 is driver gear 3 is driven gear. Therefore, how I can write the velocity ratio now? This is the driven gear now. N3 by N2 is equal to T2 by T3. This is for pair of 2 and 3. Similarly, if I write it for the third and fourth assembly now from 3, the speed has reached up till gear 3. From this gear 3, I want to transmit the power to gear 4. Now gear 3 becomes the driver gear and gear 4 becomes the driven gear. So ultimately we are reaching to the point of our driven gear itself, that is gear number 4. Now velocity ratio between gear 3 and gear 4, how we can write now? N4 by N3 is equal to T3 by T4. That is the thing we need to achieve now. So how I can write? Gear 3 is driving gear 4, which means N4 by N3 is equal to T3 by T4. So you can see we have got the velocity ratios for all the combinations, gear 1 to 2, 2 to 3 and 3 to 4. But generally what do we need? We need the velocity ratios for N4 and N1. So generally what do we need? The velocity ratio. We need the velocity ratio between N4 and N1. Yes. Why? Because of this entire assembly, N4 is the driven gear, N2 is the N1 is the driver gear. So we need for this one. That is the reason that we have estimated step by step for all the gears also. Now, how we can write all these things together? Let us see. So the velocity ratio, yes, you can see here in the picture here. I am showing you here. See, from this gear, I want to transmit the power to this gear. See, from this gear, where it is meeting this red colored gear here at this point. Now, from purple color is the driver gear, red is the driven gear. Velocity ratio between the purple gear and the red gear is estimated. Once it is estimated, then the mechanism has to be moved between the red gear and the green gear. So now we have to find the velocity ratio between the red gear and the green gear. Now for the second case, it is now this becomes the driver gear and this becomes the driven gear. So now ultimately coming to the point where we are multiplying all them together, equation 2, equation 3 and equation 4, what do we get? When we multiply N2 by N1, that is between these two, into N3 by N2 into N4 by N3, we have got is equal to T1 by T2, T2 by T3 and into T3 by T4 we have got. So if you observe here in this above equation, which are the things which are going to get cancelled? If you observe, N2 gets cancelled, N3 gets cancelled. Similarly, T3 gets cancelled, T2 gets cancelled. So what is remaining? N4 by N1 is equal to T1 by T4. N4 by N1 is equal to T1 by T4. Therefore, the velocity ratio for a simple gear train with the idler gears, how you can write the speed of the driven gear to the speed of the driver gear is equal to number of teeth in the driver gear to the number of teeth on the driven gear. That is the equation. Or you can say that speed of the last gear to the speed of the first gear is equal to number of teeth in the first gear to the number of teeth in the last gear. This is the equation. So if you compare equations 1 and 4, 1 and 5, what you can say that whatever the idler gears you are using here, gears 1 and gear 2, they will not change the velocity ratio. From 1 to 4, whatever the velocity you want to transfer, its velocity is not changed when it is moving from 1 to 2, 2 to 3. Only the thing is to accommodate the space between gear 1 and gear 4, we are introducing these gears. Now, there is one case. Let us understand this case. The first case is gear train with one idler. So in this picture, you can see here there are two gears. This is the driver gear, which is rotating in the clockwise direction. There is a driven gear, which is also rotating in the clockwise direction. But between these two gears, there is one idler gear. So if you are now observe according to our theory, gear 1, it is the driver gear. Gear 1 is the driver gear. It is driving idler gear. Yes. This idler gear rotates in the anti-clockwise direction. See, if you observe carefully, gear 1, it is rotating in the clockwise direction. Gear 2, that is the idler gear, it is rotating in the anti-clockwise direction. At this point here, gear 2 rotates in the anti-clockwise here, and it is driving gear 3. So again here, you have to remember the things carefully. Now, what you can say that according to this figure, if odd number of idler gears are used, yes, between the driver gear and driven gear, there's a small hint I am giving you. If between the driver gear and driven gear, these idler gears which you are using them, if they are odd number, that is 1, 3, 5, 7, so on. If they are odd numbers, then the direction of rotation of the driver gear, keep in mind, direction of the rotation of the driver gear is same as the direction of the rotation of the driven gear also. That is the thing we have written here. If odd number of idler gears are used, the first gear, that is the driver, and the last gear driven will rotate in the same direction. That is when we are using odd number of idlers. Similarly, if we are using even number of idlers, let us see that one. Gear train with 2 idlers. See. So here if you observe in this picture, we are having 2 idler gears between driver gear and driven gear. Here driver gear, gear 1 rotates clockwise, gear 2 anti-clockwise. If you see here again, gear 2, this is anti-clockwise, gear 3 clockwise, anti-clockwise. 1 minute students, 1 minute, 1 minute. I am sorry here. Gear 3 should rotate anti-clockwise. Gear 3 should rotate clockwise direction. Gear 3 should rotate in a clockwise direction. And again, the gear 4 will rotate in the opposite direction of gear 3, it is anti-clockwise direction, opposite of gear 3. So if you observe this sketch carefully, what you can understand clearly that if you are using even number of gears, idler gears, even number of idler gears. So in this 4 gears combination, gear 2, gear 3, idler gears. So initially gear 1, it is rotating in the clockwise direction. You can see here, opposite to this, it rotates in the anti-clockwise direction in gear 2. Similarly, gear 3, opposite to gear 2, rotates in the clockwise direction. Again, with 3 and 4, gear 3 is in clockwise, so automatically gear 4 should rotate in anti-clockwise. So what it means, if we are using idler gears which are even in number, that is 2 and 3, if you observe carefully. So as I was saying, if we are having even number of idler gears, always keep in mind the direction of rotation of the driver gear and the direction of rotation of the driven gear, both are in opposite directions. So many times a small question is asked regarding this in the examination, that if there are 8 gears in the position and there are 6 gears are the idler gears, then what is the direction of rotation of the driver gear and driven gear? Option A, same. Option B, opposite. Option C, neither A or B. So depending upon the even number of idler gears. So how many you are having? 2 you are having. If you are having 2, 4, 6, 8 and so on, if there are idler gears, then the direction of rotation of both the driver and the driven gear, it is opposite in nature. Keep this in mind. So always have this concept in your mind. if we are having odd number of idler gears, that is 1, 3, 5, 7, 9, then what happens? The first gear and the last gear I will rotate in the same direction. If we are having even number of idler gears, that is 2, 4, 6, 8, and so on, then the first gear, that is the driver gear, and the last gear, which is the driven gear, will rotate in the opposite direction. These are the things you need to know. Now, moving on to the next slide. Compound gear train. So this is the second type of gear train which is there for your syllabus. In the picture right now, what you can see here, this is nothing but a gear train which is having 4 gears. This is gear 1, this is gear 2, then there is another one, that is gear 3. This is the gear 3, outer larger diameter, smaller diameter is gear 2, and gear 4. When we were discussing simple gear train, I told you one important point, that for each shaft, if there is only one gear, remember, for each shaft, if there is only one gear, it is simple gear train. But for compound gear train, if for each shaft, minimum 2 or more than 2 gears are there, in each shaft, minimum 2 or more than 2 gears are there, then we particularly call it as a compound gear train, which right now you are seeing in this figure. This is the front view of the 4 gears which are mounted on 3 shafts, shaft A, shaft B, shaft C. Here, this is the front view. The same you are seeing the top view here. So in the front view, you can see that gear 1, it is meshing with gear 2. But gear 3, where it is meshing? It is meshing with gear 4. It is not meshing with gear 1. That is the reason that we have shown here dotted lines. That is the imaginary lines. But that mechanism you can understand directly here in the top view. So in the top view, you can see this is gear A, which is meshing with gear 2 at this particular point. So gear, that is gear 1, it is meshing with gear 2 at this particular point. Similarly, gear 3 is meshing with gear 4 at this particular point. But what about gear 2 and gear 3? What about gear 2 and gear 3? They are both present on the same shaft itself. So if you observe carefully, gear 2 and gear 3, where they are present? They are present on this same shaft itself. So therefore, what you can say here, both the gear 2 and gear 3, they are present on the same shaft B itself. So now we have to derive the velocity ratio for a compound gear train. So in a compound gear train, once more I will repeat, on each shaft, minimum 2 or more than 2 if gears are present, we call it as a compound gear train. So the shaft A is having only one gear in this picture. Shaft B is having 2 gears, that is gear 2, gear 3. Shaft C is having only one gear, that is gear 4. So here from a driver gear to the driven gear, the power has to be transmitted continuously. So let us see how it is being transmitted. Now N1, N2, N3, N4 be the speeds. Yes, N1, N2, N3, N4 be the speeds with T1, T2, T3, T4 with the number of teeth on gears 1, 2, 3, and 4 respectively. Yes. One by one we shall go. First we shall take this combination for finding the velocity ratio with respect to the number of teeth. So this is the first combination, gear 1 and 2, the velocity ratio. So gear 1, it is driving gear 2. We have the direction also, gear 1 rotates in the clockwise direction, gear 2 in the anti-clockwise direction. So what happens now? Velocity ratio is N2 by N1 is equal to T1 by T2. This is equation number 1. Similarly, if you move on to the next slide. Now, gear 2 and gear 3, how they are mounted? They are mounted on the same shaft B. Yes. So if you observe one very important point here, that is, yes, from 1 to 2, the velocity ratio is estimated, right? But on 2 and 3, 2 and 3, what are they? They are two gears which are mounted on a same shaft. So here the shaft B, at whatever speed it rotates, both gears N2 and gear number 2 and gear number 3, they will also rotate at the same speed. Keep this in mind. Once again, I am repeating here. Shaft B, it is common for which? Gear 2 as well as gear 3. So shaft B, it is common for both these gears 2 and 3. So with whatever speed the shaft B it is rotating, even the gear 2 and gear 3 also rotate the same speed. But only the thing is, if you observe in the front view, the diameter of gear 2 is smaller, which means we are having a less number of teeth. Similarly, the diameter of gear 3 is more, which means there are more number of teeth, which means even though both the speeds are equal, that is N2 and N3 will be equal as they are mounted on the same shaft, but their teeth T2 and T3, they are not equal to one another. Keep this in mind. Once again, I'll explain. From one, power is transferred to 2. That we have written the equation always right now. But now if you observe 2 and 3, they are mounted on the same shaft itself, which means with whatever speed the shaft B is rotating, the same speed is given to gear 2 as well as gear 3, which means N2 is equal to N3. But in the front view, if you observe, gear 2 it is having smaller diameter, which means less number of teeth, and gear 3 is having a larger diameter, which means large number of teeth. When you are comparing gear 2 and gear 3, the number of teeth, they are not the same. The speeds may be same, N2 is and 3 may be same, but the number of teeth, T2 and T3, they are not same. These are things you need to remember. So now moving on to the next slide. See, gear 2 and gear 3 are mounted on the same shaft, that is the B itself, which means when gear 2, yes, if you observe here in this picture also, you can observe here carefully. See, if you assume this as gear A, gear 1, it's a shaft A, it is giving its energy to this one, that is gear 2 present on shaft B. See, how many teeth are there if you count here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Around 14 teeth are present on circular, smaller diameter. If you observe both these gears, they are mounted on the same shaft itself, that is B itself. See, they are rotating with the same speed, both these, that is a yellow colored gear and the purple colored, blue colored gear. But the thing, if you observe, the number of teeth, they are different. And this third gear, it is meshing with the final gear, driven gear. So yes, both are rotating in the same direction, no doubt. Gear 2 and gear 3, they rotate in the same direction, but their speed and direction is same, but the number of teeth is different. That is the things they have highlighted here. That is gear 2 rotates, gear 3 also rotates in the same direction at the same speed, but the thing is we are having a different number of teeth. So now how can write? Directly we'll go for writing the velocity ratio between gear 3 and gear 4. So this velocity ratio, gear 3 becomes the driver gear, gear 4 becomes the driven gear now. That is N4 by N3 is equal to T3 by T4. So these are the things. Now how I can write now here? The velocity ratio of the gear train, how we can write? It is obtained by multiplying the equations 1 and 2. What do we get? N2 by N4 is N2 by N4, N2 by N1 into N4 by N3 is equal to T1 by T2 into T3 by T4. These are things. So N2 by N1 is the velocity ratio which is obtained between gear 1 and gear 2, that is T1 by T2. Similarly, between 3 and 4, T3 by T4, that is we have obtained here. But if you observe, as per my observation, as I was telling you that here both these, that is the yellow color second gear 2 and gear 3, they are rotating with the same speed, which means in this equation n2 is equal to n3. When n2 is equal to n3, what happens? Both these gets cancelled. Why they get cancelled? Because n2 and n3 are mounted on the same shaft B itself. So finally what we get, n4 by n1 is equal to t1 by t2 into t3 by t4. How we can write now? N2 is equal to N3, as gear 2 and gear 3 common to same spindle, that is the shaft B itself. Therefore, equation 3 becomes N4 by N1 equal to T1 by T2 into T3 by T4. Therefore, what you can write? Velocity ratio is nothing but it is the speed of the driven gear, that is the last gear, to the speed of the driver gear, that is the first gear, which is equal to, now if you observe the relation, what becomes product of the number of teeth on the driver gear to the product of the number of teeth on the driven gear. This is the relation, product of number of teeth on the driver gear to the product of number of teeth on the driven gear. This is the relation for finding the velocity ratio for compound gear train. So always keep this in mind. For compound gear train, speed of the driven gear to the driver gear is equal to product of number of teeth on the driver gear. Product of number of teeth on the driver gear to the product of number of teeth on the driven gear. This is the principle for finding the velocity ratio of a compound gear train. Thank you, students.